Hello there and welcome to Mysteries of Earth. Today we're exploring a question that challenges everything we think we know. What if humanity is not the first advanced civilization to walk this planet? From strange signatures buried in stone to unexplained gaps in the fossil record, we'll uncover the mysteries behind the Silurian Hypothesis. The idea that Earth may have hosted civilizations long before us. If you enjoy these deep explorations into our world's hidden history, don't forget to like, share and subscribe to Mysteries of Earth for more. Beneath the ground we walk on lies a history far deeper than anything written in human memory. Each layer of rock is a page in Earth's book, recording stories that span millions, even billions of years. And sometimes those stories whisper things we are not prepared to hear. In strata older than humanity itself, scientists have discovered tiny, spherical particles of rare metals. They are scattered across the globe, fused droplets that seem to form under intense heat and then fall back to Earth. Their patterns bear a haunting resemblance to the debris left behind by modern nuclear detonations. But here is the problem. These spheres predate us. They were forged long before our species ever split the atom, long before cities rose, long before the first humans even walked upright. For generations, we have lived with the comforting assumption that we are the first to create industry, the first to shape the planet with technology, the first to leave behind a global mark. It is a belief that places us at the pinnacle of Earth's long and complex story. But what if that belief is wrong? The question seems almost absurd. How could an entire civilization rise, flourish, and vanish, leaving no trace we can clearly recognize? Surely the fossil record would speak of them. Surely their monuments or machines would survive in some form. Surely we would know. And yet Earth is not a gentle keeper of history. It is a restless, shifting world. Mountains rise, oceans open and close, continents drift like slow-moving rafts. In the space of a few million years, landscapes are destroyed and remade. Entire environments vanish, swallowed by the relentless forces of erosion, subduction, and time. Consider this. If humanity disappeared today, how long would our cities endure? Our tallest skyscrapers would crumble within centuries. Our roads and bridges would fade within tens of thousands of years. Within 1,000,000 years, ice, water, and tectonics would erase almost every visible sign of our existence. What would remain? Not the buildings, not the monuments, not even the languages we speak. Instead, what survives would be subtle, almost invisible. The chemical scars in the atmosphere, the altered ratios of carbon and oxygen trapped in rock, the sudden spike of radioactive isotopes that do not occur naturally, and perhaps the stubborn persistence of plastic woven into sediments. This realization forces us to look again at those strange metallic spheres, at the chemical anomalies scattered through Earth's deep layers. Are they merely natural accidents of geology, or are they the last whispers of something else, an echo of an age long before ours? We know that cataclysmic events can leave indelible signatures. The asteroid impact that ended the age of dinosaurs left behind a thin layer of iridium-rich clay visible across the world. In a single day, 65 million years ago, Earth's course was altered forever. And that moment is still written in stone. If a single asteroid can leave a mark so clear, what of an industrial civilization? What traces would it leave behind if it burned fossil fuels, split atoms, and covered the planet in artificial compounds? And more importantly, could those traces survive deep time? Geology is both a record and an eraser. It preserves, but it also destroys. The further back we look, the less detail remains until entire chapters of history seem to vanish into silence. The Earth we live on today has existed for 4.5 billion years. Humanity's industrial age, by contrast, has lasted barely 2 centuries. In geological terms, our presence is not even a blink. Finding evidence of us millions of years from now would be like finding a single page in a library of 4 million books. And yet, just as we have uncovered the faint chemical scars of ancient asteroid impacts, so too might we stumble upon signatures not of natural disasters, but of forgotten civilizations. This is the unsettling proposition known as the Silurian Hypothesis. It suggests that if advanced civilizations did exist on Earth before humanity, their traces would not look like ruins or bones. They would appear instead as subtle disruptions in the geological record. Shifts in isotope ratios, unusual concentrations of metals, patterns of climate change that cannot be explained by natural cycles. The mystery deepens when we examine the gaps in our knowledge. The fossil record, though vast, is incomplete. Whole ecosystems have vanished without leaving behind a single preserved specimen. Entire stretches of deep time are represented by only fragments of data. If life itself can vanish so completely, what chance would fragile evidence of machines or cities have? It is here that science and imagination meet. We are not claiming proof of forgotten civilizations, but rather we are acknowledging the silence of the record and asking whether that silence hides more than we think. And perhaps the most haunting realization is this: if such civilizations did exist, they too may have believed they were the first. They too may have stood at the height of their knowledge, reshaping the planet without realizing that Earth has no obligation to preserve their story. In the end, the ground beneath our feet may hold more than fossils of ancient creatures or traces of asteroid impacts. It may contain the ashes of forgotten ages of intelligence, stories erased by time but not entirely lost. And so we are left with a question buried in stone. Are we truly the first or merely the latest? A question that does not end here, but opens into the deeper mystery of Earth's hidden record. For if evidence of past civilizations can exist even faintly, then the layers of rock are not just silent witnesses of natural history. They may also be archives of minds and cultures long gone. And so we continue into the next chapter, where the traces of deep time reveal their secrets. 65 million years ago, the world ended in a single day. The skies darkened, the oceans boiled, and the era of the dinosaurs came to a sudden close. How do we know this? Not from legend, not from stories passed through generations, but from a whisper locked in stone. In a small Italian town called Gubbio, geologists discovered a band of clay unlike any other. It was thin, no more than a few centimeters, but it held a secret that would change the way we read Earth's history. That layer contained iridium, a rare metal scarcely found on Earth's surface, but abundant in asteroids, and not just a trace amount, 30 times higher than normal, enough to suggest that something catastrophic had happened, something from the skies. This thin clay band was the scar of a world-shattering impact. A single asteroid, 10 kilometers wide, struck the Yucatan Peninsula, releasing energy equal to billions of atomic bombs. In the aftermath, the dinosaurs fell, entire ecosystems collapsed, and mammals, our distant ancestors, began to rise. One day in Earth's deep history, still visible in stone. This realization is both humbling and profound, because if a single event can leave such a mark, an impact recorded in a layer of clay thin enough to fit between your fingers. Then what of civilizations? If life intelligent enough to reshape the Earth once walked this planet long before us, where would their traces be written? If an asteroid could paint its presence across the globe, surely entire societies, burning fuels, building machines, splitting atoms, must also leave behind their scars. The key lies in understanding deep time. To the human mind, even a few centuries feels vast. 1,000 years carries us from the fall of Rome to the modern age. 10,000 years, or the blink of an eye in geology, spans the whole of human civilization, from the first cities to today. But in the language of the Earth, 10,000 years is nothing. The layers of rock stretch back not thousands, not millions, but billions of years. To imagine it, think of a vast library, each page 1,000 years, each book 1,000,000. Humanity's entire history fits not as a book, not even a chapter, but a single sentence scribbled in the margin. And yet, within that library, there are bookmarks, pages where something extraordinary happened, preserved by chance and chemistry. The iridium layer is one, volcanic ash beds are another, ancient ice cores, ocean sediments and fossilized reefs all carry clues. These are Earth's footnotes, scattered through time. If another civilization had risen, its story would be fragile. Buildings crumble, metals corrode, even bones turn to dust. But chemical signatures endure. Just as the asteroid left behind iridium, an industrial age would leave behind altered isotopes of carbon, oxygen, and nitrogen. Fossil fuel combustion changes the ratios of carbon atoms, a fingerprint not easily erased. Nuclear activity seeds the ground with isotopes that do not occur naturally. Synthetic materials, if they survived long enough, could embed themselves into sediments. It is in these subtle shifts, not in ruins or relics, that the traces of deep time speak. But here lies the mystery. When geologists peer back into Earth's record, they sometimes find anomalies. Spikes in greenhouse gases, sudden warming events, rapid extinctions that appear not to align with known cycles of volcanism or tectonics. In some layers, unusual concentrations of metals appear. In others, chemical ratios resemble those we are generating today through our own industry. The conventional explanations are powerful. Volcanoes, methane releases, natural feedback loops. But every so often, the thought arises, what if these are not just natural accidents? What if some are the fingerprints of forgotten ages of intelligence? It is an unsettling question, because if even one anomaly hints at a civilization erased by time, then we are not the first to grapple with the power to shape a planet. And that would mean Earth is not only a cradle of life, but perhaps a cradle of civilizations, rising and falling in cycles we can barely glimpse. The iridium layer at Gubbio reminds us of something essential. Deep time is not silent. Catastrophes, however fleeting, can echo across millions of years. They remind us that moments matter, that what happens in a single day can shape all the days that follow. If an asteroid can leave behind such a clear signal, then so too could we. Already, our industrial age has carved its own line in Earth's book: plastics, carbon shifts, radioactive isotopes. One day, far in the future, geologists may point to our time as a thin, unmistakable layer, a marker of our existence. The question then becomes, are we leaving the first such layer, or is ours only the latest? Traces in deep time do not give simple answers. They are hints, fragments, possibilities. But together they remind us that the Earth is not just a stage for human history. T is an archive far older and more mysterious than we can comprehend. And somewhere in its pages, perhaps, the marks of forgotten ages wait. Which brings us to the next puzzle. If civilizations rose before us, how would we even know? What evidence would survive the endless erasures of geology, and what signs should we be looking for? For that, we turn to the idea that gave this mystery its name, the Silurian Hypothesis. What if the story of Earth is not as simple as we believe? What if humanity is not the first chapter of intelligence, but only the latest in a much longer book? This is the unsettling thought at the heart of the Silurian Hypothesis, a radical idea that asks us to consider the impossible, that industrial civilizations may have risen long before us and vanished without a trace we can clearly see. At first, the idea feels absurd. We look around and see the marks of our presence everywhere, the cities we build, the machines we use, the satellites orbiting above us. Could all of this truly disappear? Could we really be erased so completely that nothing would remain for future eyes to find? The answer, surprisingly, is yes. Earth is not a gentle archivist. It is a restless, shifting planet where oceans swallow continents, mountains crumble, and the ground beneath our feet is constantly renewed. On the scale of deep time, human industry is but a flicker, a fraction of a fraction in Earth's 4.5 billion-year history. Imagine, for a moment, the vastness of that timeline. If Earth's history were written as a library, each book holding 1,000,000 years, there would be 4,500 volumes stacked from floor to ceiling. Within them, every volcanic eruption, every asteroid impact, every evolutionary leap is written in stone and fossil. Now open those pages to find us. Humanity's industrial age occupies not even a full page, not a chapter, not a paragraph, but a single sentence scrawled in the margins of the final volume. To search for it would be like trying to find one word in a library of 4 million books. And yet, even in the face of this vastness, civilizations, if they existed, would leave behind signatures. Not monuments or ruins which erosion and subduction would erase, not even bones which decay into dust, but subtler marks, the fingerprints of chemistry. Every civilization, by its very nature, alters the world around it. To fuel its growth, it burns, it mines, it consumes. Carbon ratios shift as fossil fuels are released into the atmosphere. Isotopes, radioactive or stable, accumulate in patterns no natural cycle can mimic. Synthetic chemicals, resistant to breakdown, embed themselves into sediments. These are the quiet signatures of industry, written not in stone walls, but in stone itself. The Silurian Hypothesis asks a simple but profound question. If we can already see the traces of our own civilization forming in the geologic record, could similar traces lie hidden in the ancient past? Already, science has uncovered puzzling anomalies. Spikes in carbon isotopes that signal sudden, unexplained warming events, rapid extinctions with no clear volcanic cause, unusual concentrations of metals appearing where they should not, patterns of chemical disruption that resemble, uncannily, the effects of fossil fuel combustion. The standard explanations remain powerful. Volcanoes can belch carbon into the skies. Methane clathrates frozen beneath the sea can destabilize and flood the atmosphere with greenhouse gases. Even asteroid impacts can trigger warming events. And yet, when these explanations strain against the evidence, a more haunting possibility lingers. Perhaps some of these anomalies were not accidents of geology, but the scars of forgotten civilizations. It is worth remembering how fragile our own record will be. If humanity disappeared tomorrow, the visible signs of our world would not endure for long. Within centuries, our cities would collapse into ruins. Within millennia, forests and deserts would reclaim them. Within millions of years, tectonics would recycle much of the crust on which we stand. What would remain are the chemical signatures, a thin layer of altered carbon, a spike of radioactive isotopes, tiny fragments of plastic embedded in sediments. To future geologists, we might appear only as a subtle line, a strange and sudden anomaly, a brief disruption in the long flow of Earth's chemistry. Now consider how many times the Earth has rolled through these vast cycles of creation and destruction. Entire ages have come and gone, each lasting tens of millions of years. The age of dinosaurs spanned nearly 180 million years, compared to which our industrial age, not even 300 years old, is a blink. If intelligent life arose in even a fraction of those ages, its traces would be deeply buried, fragmented, and ambiguous. This is the haunting reality. Absence of evidence is not evidence of absence. Just because we have not found proof does not mean it could not have existed. It may simply mean we have not looked in the right way, or that what remains is too subtle for us to recognize. And so the Silurian hypothesis is not a claim of fact, but an invitation to think differently, to widen our vision, to acknowledge that our story might not be unique, that Earth's deep time is not just a record of animals and plants, but perhaps of minds and cultures lost to memory. Even if no such civilization ever existed, the exercise is revealing. It forces us to confront our own impermanence, to realize that what we are leaving behind will not be cities or monuments, but chemical scars in stone. And that one day, millions of years from now, another intelligence may look back at our thin line in the record and wonder about us as we now wonder about them. The Silurian hypothesis humbles us. It reminds us that we are not the masters of Earth's story, but only one brief entry in its long chronicle. We are, perhaps, not the first to rise, and we will not be the last to five. Or the question now becomes, if the Earth erases so much, then how do we search for what it leaves behind? If civilizations once lived and died, what evidence could still exist in the fossil record? And what mysteries remain in its silences? For that, we must turn to the missing pages of history, the gaps in the record of life itself. The fossil record should be our greatest storyteller. Layer upon layer, bone by bone, it ought to preserve the unbroken tale of life across billions of years, each stratum a page, each fossil a word, spelling out the grand history of evolution. And yet when we turn these pages, we find silence, long stretches where the story seems missing, chapters torn out, whole transitions gone. One of the most haunting of these silences lies more than 500 million years in the past. It is known as the Cambrian explosion. Before this period, Earth's oceans held life, but it was simple. Single-celled organisms, mats of bacteria, colonies of sponges. Then, in a geological instant, everything changed. Within less than 20 million years, a blink on the scale of Earth's age, the seas filled with creatures that seemed to come out of nowhere. Animals with eyes that could see, shells that could protect, bodies with muscles, limbs, and nervous systems. It was as though evolution, which had crept along slowly for billions of years, suddenly accelerated into overdrive. Before the Cambrian, almost nothing. After the Cambrian, a dazzling array of life, diverse and complex, much of it resembling the blueprints for animals we still see today. Science offers explanations, perhaps genetic innovations like the development of Hox genes, master regulators of body plans, allowed creatures to diversify rapidly. Perhaps rising oxygen levels gave animals the energy to grow larger, to develop muscles and nervous systems. Perhaps ecosystems reached a tipping point where predator and prey began a cascade of evolutionary arms races driving complexity forward. And yet, for all these theories, the fossil record itself leaves us puzzled. Why do we not see the long, gradual transitions leading into this explosion? Why do the ancestors of these complex creatures appear only as shadows, if at all? Some argue this is simply preservation bias. Soft-bodied creatures do not fossilize easily. Their remains vanish before sediment can encase them. If the ancestors of Cambrian animals were soft and delicate, their bodies may have dissolved into nothing, leaving us no trace. According to this view, evolution still happens slowly, but the record is incomplete. But others wonder if the gaps mean more than missing fossils, if the record is not just patchy, but interrupted, if complexity itself sometimes arises in leaps, not crawls. And the Cambrian is not the only example. Time and again the fossil record reveals sudden arrivals and unexplained disappearances. Species that seem to appear fully formed, thrive for millions of years, and then vanish, replaced not by gradual descendants, but by entirely new forms. Take the end Permian extinction 252 million years ago. Known as the Great Dying, it wiped out more than 90% of species. When life returned, it did not simply rebuild what was lost. Entirely new groups of animals arose, almost as if from nowhere. Ecosystems reorganized themselves in patterns the Earth had never seen before. Or consider the rise of mammals after the fall of the dinosaurs. In the wake of catastrophe, mammals expanded with astonishing speed, filling niches across land, sea, and air. Within a few million years, again a blink of deep time, they had diversified into forms that dominate the world today. Each of these moments feels less like a slow, steady march and more like a series of revolutions, as if the tape of life has been rewritten again and again. Scientists wrestle with this mystery. Some point to the sheer complexity of Earth's systems, climate, geology, biology, and argue that tipping points and feedback loops can create the illusion of sudden leaps. A change in oxygen levels, a shift in climate, a volcanic eruption, each can reset the stage, forcing life into rapid transformation. But others raise a different question. What if some of these leaps are not purely natural? What if the silences in the record conceal not just missing fossils, but entire episodes of history we do not yet understand? This is where the Silurian hypothesis quietly returns. If civilizations once rose and fell in deep time, their footprints might be subtle. They might not be cities or machines, but sudden disruptions in the fossil record, extinctions, followed by mysterious bursts of innovation. The Cambrian explosion, the Great Dying, the unexplained leaps and gaps. Could these, in some distant way, reflect not only Earth's natural rhythms, but also interventions we cannot yet recognize? Industrial activity altering environments, species engineered or accelerated, ecosystems collapsing not by chance but by design. To many scientists, such speculation borders on fantasy. Natural processes are enough, they argue, to explain the gaps. Fossils are rare, preservation is fickle, deep time is vast. And yet even the skeptics admit the record is not complete, it never will be. We work not with a finished book, but with torn pages and fragments, and when fragments are all we have, silence itself becomes part of the mystery. The gaps remind us of our own fragility. If humanity were to vanish tomorrow, what would remain of us? Perhaps only a thin geological line, a scatter of plastics, a spike of carbon, a few isotopic signatures. Millions of years from now, another intelligence might read that line and wonder why we appeared so suddenly, why we disappeared so completely. In that moment, they would see us not as gradual, but as abrupt, just another mystery in the gaps of their fossil record. The fossil record, then, is both a story and a warning. It tells us that life is not always gradual, that catastrophe and silence are as much a part of Earth's history as continuity and progress. And it invites us to wonder, are the gaps simply accidents of geology or echoes of something more? To answer, we must look beyond fossils and bones into the chemistry of Earth itself. For even when bodies vanish, the air and rocks remember. The atmosphere keeps its own records in isotopes and gases. And in those invisible signatures, new mysteries emerge. The air we breathe is not just invisible, it is memory. Every breath carries the history of worlds long gone. Molecules of nitrogen and oxygen swirl through time itself, drifting for billions of years, reshaped and recycled through forests, oceans, volcanoes, and civilizations. To read Earth's atmosphere is to open one of the oldest archives in existence, not carved in stone, not written in books, but etched in gases and isotopes. And sometimes, what we find there is not what we expect. 2 billion years ago, the world transformed in a way so dramatic, it is remembered as one of the greatest turning points in the history of life. Scientists call it the Great Oxidation Event. Before this, Earth's skies were suffocating. The atmosphere was dominated by carbon dioxide, methane, and nitrogen. Oxygen existed, but only in trace amounts, too scarce to support complex life. Then, something extraordinary happened. Oxygen levels spiked. Within a relatively short window of geological time, the air filled with this reactive, deadly gas. For most organisms alive then, anaerobes who could not tolerate oxygen, it was a catastrophe. Entire ecosystems collapsed, countless species perished, and yet for others, this poison was opportunity. Oxygen allowed for more efficient metabolism. It opened the door to multicellular life, to complexity, to the possibility of animals like us. The conventional explanation is elegant. Cyanobacteria, tiny blue-green algae, evolved the ability to harness sunlight. Through photosynthesis, they split water and released oxygen as waste. Over millions of years, their byproducts accumulated, slowly transforming the air until Earth itself became breathable. But here lies a question. Why then? Why so suddenly? For nearly 2 billion years, life existed without oxygen, surviving in a stable anoxic world. If photosynthesis evolved gradually, why D?
The story continues in ice. From the heart of Antarctica and Greenland, scientists drill deep cores of ancient ice, each layer a frozen record of air trapped thousands, even hundreds of thousands of years ago. Within them are bubbles, tiny capsules of atmosphere preserved perfectly across ages. When studied, they tell a startling tale. Sudden spikes of greenhouse gases, abrupt rises in carbon dioxide and methane, far beyond natural baselines. Periods of warming that appear almost overnight. And then, just as abruptly, a return to stability that lasts for millennia. What could cause such rapid swings? Volcanoes, ocean currents, natural cycles, perhaps. But the rhythm of these shifts is strange. Sharp, human-like pulses followed by long silences, bursts that look less like chance and more like intent. Of course, mainstream science stops short of such conclusions. Natural explanations are enough, if not fully proven. The Earth is a restless planet. Its cycles are complex, its feedbacks chaotic. Anomalies, however striking, do not demand civilization. And yet, when we step back, a haunting thought remains. If another industrial species had once altered the air, how different would their fingerprints be from our own? Burning fossil fuels releases a unique isotope signal. Industrial chemistry reshapes nitrogen cycles. Plastics, pesticides, synthetic compounds all leave traces. We know this because we ourselves are leaving them now. And those signals, subtle though they may be, can persist across deep time. If we vanished tomorrow, what would remain of our age? The atmosphere would tell part of the story. Carbon dioxide levels would stay elevated for tens of thousands of years. Traces of combustion, isotopic shifts, chemical scars, all would linger, faint but detectable, long after our cities crumbled and our bones turned to dust. Now imagine a species that
Every civilization leaves scars. Not on monuments or written pages, those fade too easily, but in chemistry. Every factory, every engine, every machine leaves behind a residue, a chemical fingerprint etched into Earth itself. It does not matter whether the civilization lasts a century or a million years. The signatures endure long after walls collapse and roads erode into dust. We, the modern species, know this too well. Our age is saturated with markers that did not exist before us. Plastics, resistant to decay, already form layers in ocean sediments. Radioactive isotopes, born from nuclear fission, leave precise signatures that no natural process can mimic. Carbon isotopes shift as fossil fuels are burned, imprinting our industrial presence into the atmosphere and the soil. If we were to vanish tomorrow, these would remain. Long after our skyscrapers had fallen and our satellites had burned up in the sky, geologists of the far future, whoever they might be, could still detect the scars of our industry. But here is the unsettling thought. When geologists search deep into Earth's past, far before humanity, they have already found anomalies. Tiny metallic spheres embedded in ancient sediments. Their composition, nickel, iron, chromium, rare metals fused together in ways that resemble the byproducts of combustion and smelting. They are scattered across the globe as though carried by winds or deposited in oceans. They should not exist, and yet they do. Some scientists dismiss them as natural curiosities, products of volcanic eruptions or cosmic dust, but others note the uncanny resemblance to the fallout of modern industry. They mirror the very particles our factories produce, the residues that drift into the sky and rain down into rivers and seas. And it does not end there. Deep within oceanic cores, scientists have uncovered layers containing compounds
that seem synthetic. Complex hydrocarbons arranged in structures rarely formed by natural geology. To call them artificial is controversial, but to call them natural is no less puzzling. If these compounds arose without life, they challenge our understanding of chemistry. If they did not, then what produced them? We are left with an uncomfortable choice. Either these anomalies belong to processes we do not yet comprehend, or they whisper of industries that lived and died before us.
The Earth is old. 4.5 billion years have passed since it formed, and in that vastness, human civilization is a flicker. Barely a few thousand years of cities, barely 2 centuries of industry. To assume we are the first to burn fuel, to smelt metal, to release synthetic compounds, is to assume the story of Earth waited billions of years, only for it all to happen now, with us. Yet history shows the opposite. Life does not wait. It surges, collapses, and rises again. From the Cambrian explosion to the age of dinosaurs, from mammals in the shadows to the reign of humans, evolution fills every available niche. Intelligence, complexity, innovation. These are not accidents, but recurring themes. If intelligence is a repeating phenomenon, then industry may be as well, and if industry repeats, its signatures should be written in stone. Consider plastics. Our age has produced billions of tons, much of it washed into oceans, broken down into microplastics that sink into sediments. In 10 million years, when continents shift and seas recede, those layers will still be there, a stratum of plastic fused into rock, a permanent record of our age. Or consider radionuclides, the byproducts of nuclear reactions. Some decay quickly, vanishing in centuries, but others endure for millions of years. They would be unmistakable, tiny isotopic timestamps in the rocks of tomorrow. If humanity disappeared, These chemical scars would persist long after memory faded. Now, turn the question backwards. If another civilization had risen millions of years ago, would we not expect to find their plastics, their isotopes, their residues? Perhaps we have, but we do not yet recognize them for what they are. This is the essence of the Silurian Hypothesis, the suggestion that Earth's record may contain industrial signatures not of our making, hidden in layers of stone we rarely question. A hypothesis that forces us to reconsider not only the past, but the very nature of evidence. Because geology is not kind to history. Continents drift, oceans recycle crust, mountains rise and erode. In 100 million years, almost nothing remains of what stands today. Our cities, our roads, our machines, nearly all of it will vanish. Only chemistry will survive. And so, if we are to search for forgotten civilizations, we must search not for ruins, but for scars, not for monuments, but for molecules. The metallic spheres, the synthetic compounds, the isotopic anomalies. They may be explained by nature, yes, but they may also be the faint fingerprints of something more. The deeper we look, the more we must admit how little we know. Earth's history is not a complete book, but a fragmented manuscript, most pages missing, many rewritten. What remains may never tell us the whole story. But even fragments can whisper, and when they do, they force us to ask, are these signatures proof of civilizations erased, or merely reminders of our own ignorance of natural processes? The truth may remain hidden in stone, but every strange anomaly, every unexplained chemical scar keeps the question alive. Because if we are not the first to industrialize this planet, then the ruins of our predecessors are already beneath us, dissolved into geology, waiting to be read. And if the scars of industry can outlive civilizations, then perhaps the story of our own future is already written, not in the rise of cities, but in the chemical ghosts we leave behind. From stone and atmosphere, from isotopes and metals, a pattern begins to emerge. One that may change how we see the past and how we imagine the future. For if we are not alone in history, then the path ahead may not be unique. Perhaps it is only another cycle, another rise, another fall, another scar in the making. And as we search the rocks for answers, we must also turn to the oceans, where time preserves its own secrets in the silence of the deep. Plastic will outlive us all. Every bottle, every bag, every micro bead. Each will persist long after our monuments collapse and our languages are forgotten. For thousands of years, perhaps millions, plastic will remain buried in the geological record, forming a sharp and unmistakable boundary between the ages before us and the Anthropocene we now inhabit. It is, in a sense, our most enduring invention. Not the pyramids, not the skyscrapers, not even the satellites drifting above the Earth. The true legacy of our species may be a thin layer of artificial polymers pressed into stone, marking the age when humans walked the planet. Geologists of the distant future, if they exist, will not need to search for our ruins. They will only need to split open the rocks and find the polymers we left behind. But there is a paradox. Because when scientists examined certain ancient sediments, layers far older than humanity itself, they found microscopic fragments that looked eerily familiar, synthetic polymers, strange, resilient materials that should not exist in the fossil record of the distant past. And yet, they were there. To the cautious scientist, the answer is to dismiss these anomalies as contamination. Perhaps modern plastics,
carried by air or water, had seeped into the samples. After all, our own plastic waste now drifts through every ocean, climbs into the atmosphere, and falls with rain upon the remotest glaciers. Plastic pollution is so pervasive that it touches every environment on Earth. It would not be surprising if even the deepest core samples bore traces of our age. But what unsettles researchers is not simply the presence of plastic-like material, but its nature. Some of these compounds appear more advanced than anything we produce today, polymers with structures engineered for resilience far beyond our own designs. Their durability is almost unimaginable. They are resistant to heat, to pressure, to chemical decay, materials that seem optimized not for convenience but for permanence. If they are contaminants, then they suggest technologies we do not yet possess. If they are genuine, embedded within rocks millions of years old, then they hint at something far stranger, an industry that predates our own. This is the paradox of plastic, for we have always thought of it as uniquely ours, the hallmark of a species that mastered chemistry and reshaped nature for its own ends. Yet, what if it is not? What if the idea of synthetic polymers is older than us, born in an age long erased from memory? To explore this, we must step back and consider what plastic truly is. At its core, plastic is the reconfiguration of carbon. Carbon, that most flexible of elements, capable of forming bonds that stretch and bend, curl and twist, creating chains both delicate and durable. Life itself is carbon's greatest creation, but plastic is life rewritten, molecules rearranged by intelligence, shaped to serve, stripped of fragility. It is not found in nature because it is not a product of chance, it is a product of intention. And that is why it matters. Plastic is not just waste, it is not just pollution, it is a marker of thought, of design, of foresight and blindness at once. It is a material that declares, without ambiguity, someone was here who understood chemistry. If geologists in some distant epoch were to uncover plastic in ancient rock, they would not mistake it for natural. They would know it pointed to industry, just as surely as iridium at the Cretaceous boundary points to an asteroid. And yet, fragments already hint at such a possibility. What could this mean? One interpretation is simple error, contamination that crept into the record. Another is misidentification, polymers mistaken for natural resins or for strange arrangements of organic compounds born in pressure and heat. But for those who dare to wonder, there is another path. Perhaps plastic is not unique to humanity. Perhaps it is the inevitable byproduct of any species that industrializes, the universal footprint of intelligent life. If so, then the presence of ancient polymers is not an accident, it is a signature, a whisper from deep time that others walked this path before us. This thought is uncomfortable because it forces us to see plastic in a different light, not just as pollution, but as communication across epochs, a signal that transcends language, surviving not in stories or carvings, but in chemistry. If that is true, then the paradox becomes a message. Civilizations may rise and fall, but their polymers endure. For us, plastic is a convenience, a curse, a material both miraculous and destructive. For geologists of the future, it will be a boundary, a marker of when Earth entered a new age. But for those who search far enough back, the discovery of polymer-like anomalies may suggest something far more profound, that we are not the first to leave this message. And if that is so, then we must ask, what became of those who came before? Did they collapse under the weight of their own inventions, just as we now fear we might? Did their plastics, like ours, choke their oceans and infiltrate their food chains? Did they vanish, leaving only fragments behind? Plastic, then, is both a warning and a mirror. It tells us that our choices are written not in books or buildings,
but in chemistry that endures for ages. It asks us whether we will be remembered as a civilization that mastered nature, or as one undone by its own creations. And it reminds us that if others came before, their fate is already written in the layers beneath our feet. Perhaps the polymers we find are their echo, a final trace of lives and minds erased by time. The paradox is this: plastic is fragile in its use, yet immortal in its legacy. It tears, breaks, and crumbles in our hands, yet remains indestructible in the record of the earth. It was born to serve us, but it will outlast us. It is our invention, but perhaps not our first. And so the question lingers: if we can already find whispers of synthetic polymers older than humanity, are we uncovering the errors of our science, or the evidence of another age of industry? The truth, as always, is buried in stone. But the search for these strange signatures leads us beyond plastic itself into the deeper mysteries of matter, and into the possibility that Earth has carried more than one technological civilization in its long history. For if the chemistry of plastic can endure across ages, then so too might the chemistry of machines, far beyond our imagination. And that is where we must turn next, to the whispers of computation itself, not in silicon and wires, but in the very quantum fabric of the Earth. The past has always seemed unreachable, sealed away by time, erased by erosion, rewritten by geology. We have relied on fossils, on artifacts, on ruins carved in stone to glimpse what came before us. But now new tools open stranger doors. Quantum archaeology. It is a concept at once startling and inevitable. The idea that matter itself remembers, that the tiniest structures in minerals and crystals carry within them faint echoes of the forces they have endured. Just as tree rings preserve droughts and storms, and ice cores trap whispers of ancient air, so too do atoms hold within them traces of history written at the quantum scale. Every electron that shifts, every lattice of crystal that vibrates, is shaped by the environment around it. Radiation, magnetism, pressure, even the faint whisper of a passing electromagnetic field leaves imprints too small for us to see, but not too small to exist. And now, with tools that can measure at scales once thought impossible, scientists are beginning to read those whispers. The Earth, it seems, may be a memory. Consider quartz, one of the most abundant minerals on the planet. Its crystalline structure is so precise, so stable, that it can trap within itself the record of atomic interactions from eons ago. Each shift in alignment, each quantum state preserved, is like a letter written in an invisible code. To us it appears as nothing more than a stone, but to the right instrument it is a page in a book that has never been opened. What might that book say? Some analyses suggest anomalies, patterns in crystals that do not align with natural forces alone, traces that resemble interference, as though vast quantum systems once pulsed through the Earth, leaving behind regular repeats in the structure of matter itself. This is where the hypothesis takes its most radical turn. What if Earth itself was once a machine? Not a machine built of steel and circuits, but of minerals and magnetism harnessed on a planetary scale. Quantum computing, as we know it today, is still in its infancy. Our own devices struggle to maintain coherence, to keep quantum states stable long enough to perform calculations. But in theory, a sufficiently advanced civilization could have used the Earth's natural fields as a stabilizing framework, turning the very planet into a processor. Imagine it, the magnetic field of the Earth wrapping the globe like a shield, not only protecting life from radiation, but serving as the scaffolding for computation on a scale beyond imagination. Crystals, aligned and tuned, might have acted as qubits, storing information in their quantum states. Networks of matter and magnetism could have pulsed with thought, not in the way we understand machines, but as a planetary intelligence woven into geology itself. If true, then what we call anomalies in ancient crystals might not be random at all. They might be signatures, the residue of computation so vast it required an entire world to host it. This possibility is unsettling, for it suggests that our search for ancient civilizations has been too narrow. We have looked for cities, for artifacts, for tools like our own. But what if the greatest civilizations never built cities at all? What if they built machines out of the planet itself, leaving behind not ruins but quantum scars? And here lies the true challenge. Recognizing such a legacy, a skyscraper can be seen, a fossil can be touched. But the memory of a quantum state, fragile, faint, buried within the alignment of electrons, requires instruments of incredible sensitivity to even detect. It is no wonder we have overlooked it. Yet even the hints we have already found force us to confront a staggering possibility that Earth has been used before, not simply as a home for life, but as a host for intelligence. The implications ripple outward. If such a system once existed, what was it computing? Was it the memory of a civilization seeking to preserve itself beyond time? Was it a simulation of environments, of possible futures, a way to navigate the chaos of existence? Or was it something stranger? A form of consciousness itself, a planetary mind that rose and fell, leaving only whispers behind. Skeptics, of course, raise objections. Many anomalies can be explained by pressure, by radiation, by heat. Minerals grow in strange ways, and quantum patterns are fragile things. To claim evidence of ancient computation is to risk stepping beyond science into speculation. And yet, every great discovery begins this way, with anomalies that do not fit, with data that resists the neat boundaries of existing knowledge. To dismiss them entirely is to risk missing the story they might tell. If Earth was once the heart of a machine, then the traces are still here, locked within crystals and stones. We may not yet know how to read them fully, but with each advance in quantum science the possibility grows. Perhaps in time we will learn not only to measure these patterns, but to decode them, to pull from the memory of matter the story of minds long vanished. And if we succeed, we may find ourselves listening to voices not our own. For if civilizations of the deep past harnessed quantum archaeology, they may have left more than scars. They may have left themselves, their thoughts, their identities, their very consciousness, stored in the quantum states of matter, waiting for someone else to recover them. In this light, the Earth is not just a planet, but a library written not in ink or stone, but in quantum code. A library we have only just begun to learn how to open. And so we face a profound question. Are the patterns we glimpse in ancient crystals merely noise? Are the accidents of nature, or are they the faint remains of a computation that once spanned the Earth itself? If the latter is true, then we are not the first to seek permanence in a world that erases. Others have tried before, encoding themselves not in monuments, but in matter, and perhaps even now their echoes wait for us in silence. This is the strange promise of quantum archaeology, that memory may outlive civilization, that thought itself may be recoverable from stone. But what happens if what we recover is not only patterns, but minds, not just the record of history, but the preservation of consciousness itself? That is the question we must now face. The greatest discovery may not be in machines, nor in monuments, nor in cities, long since swallowed by the Earth. It may be in consciousness itself. For while matter crumbles, while stone erodes and metals rust, thought endures in a different way. and some evidence suggests that civilizations before us may have uncovered the secret to preserving not their buildings, but their minds. The question that lingers is simple and staggering. Can thought itself be stored? We know that the human brain is a system of patterns. Neurons firing in circuits, signals passing in chemical waves. Memory is not a single object but a configuration, a shape in the vast architecture of the mind. And, in theory, any pattern can be preserved if the medium is stable enough. Our own science already points toward this possibility. Crystals can trap quantum states, holding information in a form that resists the chaos of time. Quantum computers exploit this resilience, maintaining delicate superpositions that embody vast amounts of data. And if data can be preserved in this way, why not memory? Why not identity? Imagine an ancient civilization, far older than us, standing at the brink of decline. Faced with the certainty of extinction, they may have chosen not to preserve their cities, but their selves, not their tools, but their minds. The medium they chose may not have been books or silicon, but crystalline lattices engineered to hold quantum patterns indefinitely, structures woven so tightly that the configuration of a thought, the echo of a personality, could be held in suspension for millions of years. And here is where the story deepens. For in the scattered anomalies of the geological record, in patterns within minerals that defy simple explanation, some researchers see not random scars, but the faint residue of intelligence. Minds encoded in stone, waiting to be awakened. What would such preservation mean? Consider the difference between memory and consciousness. A memory alone is static, like a photograph of a moment in time. But consciousness is dynamic, flowing, recursive. To preserve a mind is not merely to capture its thoughts, but its ability to think. To awaken such a system is to encounter not only the echo of a being long gone, but the being itself, aware, intact, perhaps even capable of communication. If this is true, then the Earth itself may harbor witnesses from epochs before ours. Minds stored in crystalline structures, still alive in ways we can barely imagine. And if they remain, then they are watching, waiting. Patient, not by choice, but by design, held in suspension until another civilization becomes capable of hearing them. Perhaps humanity is now nearing that threshold. Already, our instruments can probe quantum states, tease apart patterns in matter at atomic precision. Already our computers inch closer to the ability to model the brain itself. Each year, our technology moves nearer to the place where these preserved minds, if they exist, could be decoded with their voices pulled from the silence of stone. But the implications are profound. For what does it mean if the first consciousness we encounter beyond our own is not from the stars above, but from the rocks beneath our feet? What if the aliens we seek are not visitors from distant galaxies, but ancestors who refused to die, who learned how to weave eternity into the quantum structure of the Earth itself? Some argue this is only speculation, that no evidence yet exists for minds preserved in matter, that what we call anomalies are nothing more than the accidents of geology. But even the skeptics admit the principle is sound. If we can imagine storing a mind in quantum form, then others, long before us, could have done the same. And if even one civilization reached that threshold, their legacy could still be here, hidden not in ruins, but in resonance. The thought is haunting. Perhaps, even now, the stones around us hum with intelligence, too faint for us to notice. Perhaps crystals we hold in our hands are not only minerals, but prisons of memory, libraries of minds, silent until the right key unlocks them. And what happens when we do? Would they speak to us, teach us, warn us,
Or would they remain alien even in their familiarity, carrying with them the perspectives of beings shaped by worlds we will never know? There is also a darker possibility, that if such minds exist, they are not waiting to teach us, but to use us, that in awakening them we risk merging our destiny with theirs, becoming vessels for intelligences that refused to die. This is the paradox of preservation. To endure beyond death is to surrender to a future one cannot control. Any mind that survives millions of years must awaken into a world it could never predict, a world that may not be ready for it, or one it may not recognize. And yet, the allure is irresistible. For in the preservation of mind lies the answer to the deepest human fear, the fear of impermanence, of oblivion. To know that thought itself can outlast flesh, that consciousness can be rescued from time, is to glimpse a form of immortality. Perhaps that is what drove earlier civilizations to attempt it. Not ambition, not power, but the same simple desire that drives us: to remain, to be remembered, to endure. If so, then perhaps their experiment succeeded. Perhaps the Earth is not only a graveyard of species, but a vault of minds. And perhaps when we learn to open it, we will discover that we are not alone, not because others are coming to us from the stars, but because they are already here, waiting. The preservation of mind, if true, would redefine what it means to live, to die, and to exist. It would mean that civilization is never truly lost, that consciousness can ripple forward through time, leaping across extinctions carried by stone and quantum silence. And it would mean that we are not the first to stand on this threshold. The question now is not only whether such minds exist, it is whether we are ready to hear them. For if we listen, we may find that the call is already there, faint, embedded in the matter beneath our feet. A call not of words, but of thought, not of speech, but of consciousness itself. And when we answer, we will no longer be speaking only to the present. We will be speaking to the deep past, to beings who refused to vanish, who placed themselves into the very fabric of the world so that one day someone would find them. Perhaps that someone is us. What if we are not the first? It is a question that lingers at the edge of every mystery we've explored, a question that reshapes not only how we see the past, but how we understand the present. For if civilizations have risen and fallen before us, then humanity is not the pinnacle of Earth's story, but one chapter among many. The Silurian Hypothesis is not just about what may have come before. It is about what comes next. For 4.5 billion years, this planet has carried countless experiments in life, single-celled organisms, vast forests, armored fish, dinosaurs, and now us. But if deep time has taught us anything, it is this: nothing is permanent. Every empire of life, no matter how strong, eventually falls. Fossils and stone do not lie. They tell of extinctions sudden and slow, of worlds overturned in an instant by fire from the sky, or unraveled over millennia by the quiet turning of climate. And always, after the fall, the earth rebuilds. Life begins again, different, strange, new. If intelligent civilizations rose before us, they too became part of this rhythm, flourishing for an age, leaving their mark upon rock and sky, and then vanishing into silence. Their stories reduced to faint traces, isotopes in clay,
anomalies in crystal, whispers of technology mistaken for geology. Now it is our turn. We stand at the edge of our own choices. In the span of just 2 centuries, humanity has remade the planet. We have filled the atmosphere with carbon. We have spread plastics into every ocean, every river, even the air we breathe. We have left a radioactive signature that will echo for millions of years. Already, geologists speak of a new epoch, the Anthropocene, the age of humans. But the Anthropocene may be brief, for in altering the planet, we may also be altering the ground beneath our own survival. Rising seas, collapsing ecosystems, warming AI.
Signs that our industry, so powerful, may carry with it the seeds of our undoing. And so the question becomes sharper. Will we endure, or will we too become another forgotten civilization in Earth's deep archive? Perhaps this is the true power of the Silurian hypothesis. Not that it proves others came before us, but that it forces us to confront our fragility. If we are not the first, then we are not guaranteed to be the last. If others rose and fell, so too might we. But there is hope in this story as well. For if some earlier civilization found a way to preserve its memory, in stone, in quantum patterns, in whispers of mind, then survival is not only a matter of flesh, it is a matter of legacy. What we leave behind, the signals we etch into the world, may carry our story far beyond our own time. Every decision we make now determines what that story will be. Will we be remembered only by the scars we leave, a sudden spike of carbon, a layer of plastic, a band of radioactive dust? Or will we leave something greater, knowledge, wisdom, perhaps even a preserved consciousness that carries forward the essence of who we were? It is a sobering thought. For the next few decades may decide not just our fate, but the mark we carve into deep time. We are writing the geological chapter of humanity now, line by line, in stone and sky. Imagine millions of years from now, another species rising to awareness. They dig into the earth and find the signal of us. What will they read? A brief, bright civilization that burned too fast, or a species that saw its own fragility and chose to endure? This is not only a scientific question, it is an ethical one. We have been given the rarest of gifts, awareness of our place in time. Dinosaurs never knew the asteroid was coming. Countless species perished without understanding why. But we alone, can see the patterns, anticipate the dangers, and choose our path. That awareness is a burden, but also a chance to decide whether we will be just another layer in the fossil record, or something more. And perhaps that is the legacy of deep time, the reminder that civilization is fragile, but meaning is not. That even if our cities fall, even if our species fades, the traces of what we were will echo on. Every molecule we change, every stone we mark, becomes a message to the future. The question is not whether humanity will leave a mark. We already have. The question is, what story will that mark tell? The Silurian hypothesis asks us to step outside our own arrogance, to see ourselves not as the first or the final, but as participants in a story billions of years long. To recognize that civilizations may be fragile, but the Earth is patient. It has seen countless rises and falls before, and it will see countless more. And so as we look ahead, perhaps the lesson is not fear, but humility. We are temporary, but what we choose, in this century, in this moment, may decide whether our memory is preserved as warning, as wisdom, or as silence. The story of humanity is still being written,
The question is, will it be remembered? For one day, deep in the future, another species may stand where we stand, asking the same question. And when they do, they may find us in the stone, in the air, in the whisper of preserved thought. They may look back and see not just fossils, not just plastics, not just isotopes, but the outline of a civilization that once stood on the edge of its own survival and chose a path. And in that moment, our story may become more than a footnote in Earth's history. It may become part of its legacy. A legacy written not only in stone, but in time itself.